Okay, Bismillah ar-Rahman ar-Rahim. This is a new topic, which is Class B amplifier. But before we discuss Class B amplifier, we go and quickly recap the previous concepts. So basically, we classify, if you see over here, we classify amplifiers. Okay, these amplifiers in two vast categories. One is the small signal and the other is the large signal. Okay, by small signal we means that the input signal is so small. So if I write for you that the input signal is so small, okay, that if you analyze that signal on the DC line characteristics, okay, this is the Q point, the midpoint, okay. So what would happen that the signal, it varies around this Q point, the variation is very small. So if the variation of the signal around this Q point is small, okay, so we call this a small signal. And this is possible, only possible, if you have a signal, the input signal, which has a smaller amplitude, like over here. In a large signal, we say that if the variation, okay, again, if I draw this Q point, if the variation of the signal around the Q point is large, so basically if this is your Q point actually, and you can see if the variation, it goes, okay, around this Q point with high variation, large variation, so we care this is a large signal. This is a large signal, and this is only possible if you have a signal at the input that has what amplitude which is significantly high, right? Okay, so we call this as large signal amplifiers. Okay, now over here the small signal amplifier. Okay, we studied this in previous chapters, in chapter number 6. All those were small signal amplifiers. Okay, these amplifiers. Now remember, this with the, on our main concern was the amplification linearity. Okay, and then the gain. So we were more looking into design and analysis aspects of its linearity and gain. So how we can maintain linearity? Linearity means that the characteristic of the output signal to be operated, okay, in this linear region. Remember, this is a linear region. This is your cutoff region, and this is your saturation region, this point. So and then the stability issues, all those things, okay, the various parameters that actually defines this linearity. And the other concern we were looking was the gain. So how to increase the gain of a small signal amplifier. And remember, we came up the idea of multi-stage amplifiers. So by multi-stage amplifier, the gain of it can be significantly, the gain of the amplifier can be increased. Then we also looked into the gain aspect, its effect on the load actually. So if you have a load, okay, that is under low load condition, under full load conditions, okay, what is the behavior of, or what is the effect of on the gain. So we also studied the behavior of load, okay, on the gain of the small signal amplifier. Now over here in this chapter number 7, when we started with class A amplifier, and we discussed that this is a large signal, so the concept is clear. And our main concern of this large signal is what is efficiency. Okay, efficiency, that how we can increase or improve the efficiency. Okay, and what are the parameters that define efficiency. Okay, so efficiency basically it comes out to be a property of your power dissipation. So if your power dissipation in a power amplifier is less, so we say this is a good amplifier, it is more efficient. Okay, and then we look into the factor of maximum power delivered to the load. So how how we can maximize the power being delivered to a load in an amplifier. So what are the techniques, or what are the ways to improve power, maximum power delivery. So this is how this classification is done. Okay, now if you see over here, further this okay, this large signal, if you see large signal, so our main concern over here is large signal. Okay, and we are more interested in studying large signal amplifiers. So you can see large signal amplifiers can be broadly classified, okay, into these three categories. One is a class A amplifier, the other one is class B amplifier, the other one is class C amplifier. We also have some more classification of amplifiers, but we stick with these three because these are included in our course, in our syllabus. So last time we studied this class A amplifier, right? This time we'll be looking into class B amplifier. Okay, this class B amplifier. So but again, to give you an idea of how these classes works actually. Okay, so if you see, it works, we can see over here physically, we can see rather we can analyze these classes of amplifier with respect to the conduction cycle. Okay, the cycle of input signal. So if you, let's suppose, if you apply an input signal, right, this is my input signal. Okay, I applied this is to a power amplifier. Okay, now at the output, okay, what sort of wave shape I get. Okay, so if I am getting a full wave shape, okay, as at output, okay, it means that the amplifier, this amplifier is operating over the entire cycle, both the positive one and the negative one of the entire positive and of the entire cycle. Okay, over here positive one and negative one. So the if amplifier, this amplifier, it operates on the entire cycle of the input signal. Like over here we call this as class A amplifier. So you can see this is quite visible that the output of the amplifier, actually it operates, the amplifier operates on the complete entire cycle input signal. Okay, now if it happens to be that the amplifier, this amplifier, okay, it operates, okay, on either the half cycle, positive half cycle, or on the negative half cycle. So basically if it operates like this, okay, depending upon, okay, the properties of an amplifier, okay, or it operates, okay, for the other half cycle, basically for the negative half cycle. So we call this as a class B amplifier. We call this as a class B amplifier. Similarly, if so, you can see the conduction angle, okay, is 180. Okay, and the conduction angle over here is 360 for class A amplifier. Okay, now if the amplifier is operated greater than 180, see over here, okay, greater than 180 and lesser than, okay, you can see this is your 270, or okay, like if it is conduction angle is in between 180 and 200 degrees, so this is known as class AB amplifier. Okay, and if this amplifier is operated lesser than 180, now remember it is operating lesser than 180 for the half cycle, negative half cycle. So and then it operates I mean to say that lesser than 180 degrees. Okay, so the angle of conduction is between 100 and 150, so we call this as a class C amplifier. So this is very simple. Okay, so depending upon the conduction angle or the of the input signal, how the amplifier operates. Okay, so we classified that operation as class A, class B, class A, B, and class C. Now the next thing that, okay, now this conduction angle will give you different values of efficiency. Okay, now if you see, if it is going to be operated, okay, for the entire cycle of the input signal over here, so the efficiency is mathematically we can prove, and we actually proved last time, that for class A amplifier, okay, 25% is the efficiency. It means that that the 75% of the remaining power is dissipated as heat inside the amplifier. Likewise, in class B amplifier, okay, which operates for 1/2 cycle, so the efficiency is quite good. It is increased, it is 79%. Okay, so it means that the rest of the 21% is dissipated as heat, and 79% is delivered to the load, right? Okay, now for class C amplifier, we say, okay, this efficiency, now it is the conduction is lesser than 180. Okay, so its efficiency is better, okay, than class B and class C. Okay, we can prove this later on. Thank you.